How you doing, Year 10s? Welcome to another video. This is still part of the What are the types of chemical reactions series, and this time we look at redox. Let's get into it. Okay, so what are the types of chemical reactions? And in this volume we look at redox reactions. Understanding and outcomes, you need to be able to identify a redox reaction as the gain of oxygen, and the loss of oxygen is called reduction. Gain of oxygen, oxidation. We also need to apply the saying of oil rig, which is talking about whether a species has been oxidized or reduced. So a redox reaction, as the name suggests, contains two parts, a reduction process and an oxidation process, redox. An oxidation reaction occurs when you have addition of oxygen. So if something has gained oxygen, it can be considered as undergoing oxidation. Reduction is the opposite of oxidation. If a compound loses oxygen atoms, you can say that it has been reduced or undergone reduction. So if we were asked to identify the underlying compounds as undergoing oxidation or reduction, well, here we have the iron, and then on the product side, the iron has gained oxygen, so it has undergone oxidation, or it has been oxidized. In the other reaction, aluminium is produced through the reduction of Al2O3. The aluminium oxide has lost the oxygen, so it's produced the aluminium. So that means that the Al2O3 has undergone reduction. So something else in the process must have gone through oxidation. And in this case, the carbon solid, look what's happened to the carbon. The carbon has gained oxygen, so it's undergone oxidation. So Al2O3 has undergone reduction, and the carbon underwent the oxidation. Write a balanced chemical equation and identify the species that has undergone oxidation and reduction. So the species means the chemical with the state. So we're identifying which chemical and in what state and what has that undergone. Has it undergone reduction or oxidation? So zinc oxide is heated to a high temperature in the presence of carbon. The zinc oxide loses its oxygen to form zinc metal and carbon dioxide gas. So we need to make sure that we get the formulas right. We have our zinc oxide. Zinc oxide is an ionic compound, so it will be a solid. Carbon, it will be a solid in its standard state, and that's formed zinc, a metal, a solid, plus carbon dioxide gas. Now, is this equation balanced? No, I've got two oxygens on the right, so I need to put a 2 out the front of the zinc oxide, which means I've got to put a 2 out the front of the zinc as well. So now let's have a look at what happens to the zinc oxide. Well, it's turned into zinc, so it's lost oxygen. When something loses oxygen, that is a reduction process. What's happened to the carbon? Well, the carbon has gained the oxygen. Gain of oxygen is known as reduction. So zinc oxide solid has undergone reduction, and carbon solid has undergone oxidation to form carbon dioxide. So our two species are ZNO solid undergoing reduction and carbon solid undergoing oxidation. Okay, we also need to be able to talk about redox reactions and electrons. Now, redox reactions are described as electron transfer reactions because electrons are transferred from the species undergoing oxidation to the substance undergoing reduction. Oil rig is a saying that we can use to help us identify what's happened to the electrons. Oil is oxidation is loss of electrons. The rig part stands for reduction is gain of electrons. So we have to make sure that we make a distinction between oxygen and electrons. Use the oil rig saying for the electron process. So if we were to write a couple of little equations to work this out, then we could have something like Zn solid, zinc solid, and it's formed zinc ions. So that means it's lost 2 electrons. So that is an oxidation process. The electrons will be on the right-hand side. If something has undergone reduction and gained electrons, like copper ions turning into copper solid, that's a reduction process. The electrons are on the left-hand side. Thanks for watching, guys. Don't forget, drop a like on the video, subscribe if you're new, and I'll see you next time.